All right, next section, arithmetic sequences and series. So the reason why they squeeze this into the textbook is because these guys are going up by a definite or down by a definite amount, which is the common difference in all of these is essentially the slope. It's how things change from one term to the next. All right. So each one of these can be considered your output as you increase by 1 each time in your domain. But what, you guys, stop it. I'm making videos. What is he doing? Okay, so stop arguing. What is the common difference and the next term in the arithmetic sequence? All right, so 23 and 24 are going to be simple. All right, these are easy ones. 3 to 15 is a difference of 12. And do we go up 12? Yes. Up 12? Yes. All right, so the common difference we'll just call D, and it's 12. And so the next term, well, we're going to go up by 12 from 39. So 39 plus 12 is going to be 51. All right, no problem. 24. Looks like from 19 to 13 is a difference of 6, and that is, it continues, so it looks like our difference of 6 in the negative, all right, don't forget if you're dropping, then you should have negative, so this would have a negative 6 slope, right, and to find the next one, we would have to go 1 minus 6, which gives us negative 5, okay? All right, now for 25 and 26, we're going to write the recursive and explicit functions for each sequence. Now this is kind of more about formatting. And so 25, what we're going to do is we're going to take our first term. This is the, I'm going to start, you know what, since it mentioned recursive first, I'm going to do that. Recursive always has a piecewise function. You have your first term, and that's when n equals 1. Yeah? Okay. Well, that doesn't sound like a fun game. Okay. Well, good. And it looks like I'm going up by 4 each time, right? So this is just the formatting for this, right? This means your first term, you started at 5, and it looks like each time you go up by 4. So I have 5. If I want the second term, okay, the next term, I would go here and say, okay, well, if n is 2, 2 minus 1 is 1, so that's a sub 1. That's 5. That was my previous term. Then I add 4. I get 9. Then, if I want the next term, I plug in a 3. I take the 9, add 4. I get 13. Then I go and take the next term, which is 4. 4 minus 1 is 3 to get the third term. Then I would actually take the 13, and I would add the 4, get 17. So this is what's called a recursive. It's like a little loop that kind of plays, all right? This is extremely important in computer science, where your new output is your new input, is your new output. It just keeps going in a cycle like that. Okay, it's extremely important, especially with creating like, well, you know, I won't do that. It's test tomorrow, so I'll just stop. So that's the recursive, all right? So explicit just means that I'm going to use the formula that is very comfortable. This is the formula that's much more easier to use. You have your first term, which is 5. You are going to add 4 because you go up 4, and then you simply throw in the n minus 1. And then that way, if you want the next term, you just plug it in. All right. Now remember, sometimes though you don't stop at the last term. Sometimes you have to find the sum. Okay. So finding the sum, 27 and 28. I want you to be careful with that. But that's it. That's the answer to 25. 26. I'm going to kind of fly through here because we have a starting point of 25. Looks like we drop a total of 7 each time, but that won't influence my first piece. But I will have a sub n minus 1 dropping 7, and that would be for any number that's greater than 1. So this is my starting point, and this is all the terms after it. That's my recursive, all set. All right, so now, again, we start with 25. We will drop by 7 each time, and we will make sure that we don't double count by putting in n minus 1. All right, so that's 26. 27. Where are we at? 5-minute mark? Okay, I'm going to keep... Can I keep going? No, I'm going to stop here. I'm going to cut this video in half, and I'll do 27 on the next one.